Born in what was then the Soviet Union, distinguished Professor Yuri Kivshar says he grew up in an environment that encouraged a passion for science.
We were not driven by money. We were driven by science itself. And I got education actually based on that taste of science and satisfaction and happiness to do very good science.
He studied physics at the Kharkiv school, founded by Nobel laureate Professor Lev Landau. At 30, Professor Kivshar became the youngest senior research fellow of the renowned Institute for Low Temperature Physics and Engineering. And then, in 1993, he came to Canberra, where he later set up his own research centre, here at the Australian National University, a centre that would pioneer metamaterials research in Australia.
And metamaterials were developing mainly for application in radars and microwave technology. And then later people took that advantages to actually use metamaterials concept, meta beyond materials in optics 3 times. So 3 times should be somewhere here, right?
Professor Kivshar is one of the founders of the field of metaphotonics.
This one for opticals.
So it's a photonics which employ properties of these metamaterials, but in the scale much smaller than wavelength of light.
As light travels much more quickly than electrons, optical fibres use it to transmit data faster and further than electrical cables. But most light-based devices are currently bulky and much larger than their electronic counterparts.
We want to reduce scale to very, very small size, and that means nanotechnology.
The first metallic metamaterials made it possible to manipulate light at a nanoscale, but information was quickly lost over short distances, limiting its applications. Professor Kivshar pioneered a new class of refractive, non-metal nanostructures that allowed for greater control and kept light trapped for longer. This technology could be used to make optical devices such as tiny sensors, ultra-thin lenses, and light-based computer chips.
I'm excited because I see new opportunities of all these new discoveries.
Professor Kivshar's main focus is fundamental metaphonic research, but he also collaborates on its commercialisation. He was part of an international team that developed metamaterial patches for MRI machines that can significantly enhance their imaging speed and resolution. Professor Kivshar has a long-standing connection with the Australian Academy of Science. He was not only its youngest fellow at the time of his nomination, but is now also a 3-time recipient of an Academy Honorific Award.
Very important achievement for me, because when I came to Australia more than 30 years ago, I did not expect that I will achieve something. I'm very happy that committee recognized my achievement to the level of medal.